Hello everybody. Today's video is talking about marginal analysis. That sounds horrible, but it's actually one of the most useful applications of calculus in the business world. So let's go ahead and apply what we learned. So you can find marginal cost, marginal revenue, and marginal profit. So let's start with marginal cost. What does marginal cost mean? Well, it's the amount it will cost to produce one additional item for a given number of items already produced. So if I'm producing 50 items and want to know how much more it's going to cost to produce one item, that's called the marginal cost. Now, how do you find that? You take the derivative. So if c of x is your cost function, c prime of x is your marginal cost function. So you can always read it as the cost to produce one additional item for any value of x. All right. Now, average cost. This is something else that gets thrown under marginal analysis, which makes sense for some of you. So, if we're producing 1,000 items, well, the easiest way to find out how much it costs per item is to divide our total cost by the number of items, which that's how you do the average cost. So take your cost function and divide it by x. So quick example, if cost of producing something is 20x plus 100, then if you do the marginal cost, you get c prime of x is just 20, and the average cost would be 20x plus 100 divided by x, which you can split that up, so it becomes 20 plus 100 divided by x. So that means for each additional item, it costs you $20 more. But the average cost of producing each item decreases as you produce more. Because that $100, which was constant in the cost function, that's getting split amongst even more items as you produce more. Therefore, the average cost goes down for each of them. All right. So we also have marginal revenue and profit, which is probably exactly as you think. Marginal revenue and profit can be found the same exact way, which means just take the derivative. But you can actually use these for a little bit more. You can find the maximums and minimum profit or revenue. You can also use this for the cost, but usually people are more concerned about maximizing profit as opposed to minimizing cost. Because even if you minimize your costs, if you're not getting any revenue in, you're not going to maximize your profit. So let's look at an exercise. So assume you own a business that refurbishes iPhones. A lot of people have them. They get busted. They need to get fixed. To do this, you need to pay for labor, parts, which can be modeled by the equation of c of x is 0.25 x squared plus 40x plus $1,000, where x is the number of phones refurbished in a single month. So from here, you can see that costs approximately $40 per item, probably in parts and a little bit of labor. The 0.25 x squared, that's probably also dealing with labor, considering you probably don't have many employees. So for each additional one, it's more of a toll. So fixing one phone by yourself isn't too bad. Fixing 5 phones by yourself gets a bit more difficult. Now, assuming you charge $80 per phone to refurbish them, we want to find the revenue and profit functions, the marginal cost, revenue, and profit functions, and how many you need to be refurbished to make the most money, so maximizing your profit. All right, so let's go ahead and take a look at what functions we get. Well, we have our cost function set already, so we don't have to worry about that. Revenue, well, we charge $80 per phone, therefore we get $80 times the number of phones, which the number of phones is x, so we have 80x. Now, for our profit, you just take the amount of money you take in, which would be your revenue, and subtract your cost. So that'll end up giving us the function of negative 0.25 x squared plus 40x minus 1,000. All right. Now, marginal cost, we take our derivative, use your power rule that we've learned. So our exponent on the x squared comes down to the front, multiplies the 0.25 to give us 0.50. and subtract 1 from our exponent. So we get 0.50x. And then the second part just comes out to 40. Our marginal revenue, well, power rule again, we just end up with 80. And our marginal profit, we can see, is negative 0.50x plus 40. Notice that the profit and cost functions look similar, except slightly off on the signs. Now, let's also look at our average cost function just because. So we can see 0.25x plus 40 plus 1,000 over x. So let's go ahead and take a look at some stuff. So go to y equals, after you turn your calculator on. Yep, that looks good. So let's go ahead and put in our regular cost function. X squared plus 40x plus 1,000. Now, all of these are positive and starts at 1,000, so we'll probably want to start there ourselves. And let's go start at -1. Now let's go to 100, assuming we can go up to 100 phones. And let's count by tens. Minimum Y, well, we start at 1,000, so whoops, only want 900. And then let's go say 2,000. All right. And let's count by hundreds. Now if we graph that, no, we're seeing our cost is going way up. So that kind of sucks. So let's make this up to 8,000. We now see, we can see the curvature, but that's $8,000 in a single month for costs. That sucks. Now let's, if we go back to y equals, let's go ahead and put in our revenue. If we graph that, we see that it goes above for a while, but it starts out below for quite some time. Now our intersection point here, remember, that is our break-even point. We don't really care about that much. All right, so now let's go ahead and go back here. Let's get rid of these. They're cluttering up all of our space. And let's take a look at our average price function. Because by doing this, we can take a look to see how much it ends up costing per item for our production. So if we graph, let's see. Not seeing anything, so that means telling me that our window's up too high at this point. So let's go ahead and change our Y minimum back to 0. And let's put this one at 1,000. And there we see our average cost function. So if we only service like 1 or 2 phones, it's extraordinarily expensive per. But over here, it's not too bad. All right. Now, let's go ahead and take a look at the next part. So finding the maximum profit. To do this, we take our function for the profit, the marginal part of it, and set it equal to 0. Which, solving for it, we get x equals 80. Now, we want to make sure that there is actually a maximum profit. So let's go back to our function and put that in. So profit is negative 0.25x squared plus 40x minus 1,000. Now if we graph that, we see it comes up and then it starts going back down again. So right here is where our maximum profit would be. So if we trace it, and we said we had 80 phones for the maximum, yep, that seems to be the top. Which what that also means is in order to maximize our profits, we need to refurbish 80 phones in 1 month, and that would yield us a profit of $600. Not great, not horrible. So hopefully you learned something, and I'll see you in class.